Welcome back, everybody. Today's learning target is I can use order of operations to evaluate algebraic expressions for a given value. So first, we got to determine what does it mean when we evaluate a variable expression. Well, what it means is we're going to replace a variable with a number and then find the value. Get it? Evaluating. And our answer is a value. So for example, if I want to evaluate the expression 6w, as you remember that means 6 times w, and if we want to do it when w equals 9, that means I'm going to take the 9 and substitute it for the w. So I have 6 instead of w, I have 9. And then I just do the calculation, and the answer is 54. So let's do another one. If I did it when w equals 3, so I would put -3 in for the w. And when you're doing multiplication or exponents, a lot of times it's a good habit to get into if you put the number that you're going to substitute for the variable in parentheses. And you'll see some examples later why this helps. So I have 6 times -3, and my answer is -18. Now, notice, because these are expressions, they have no equal sign. Therefore, we don't solve it. So all I want to see in your final answer is the number after you evaluate it. I don't want to see x equals because there's no equal sign. It won't just magically appear, I promise. In order to be able to be consistent and get the same number every time we evaluate expressions, mathematicians had to agree on a common order of operations. You may remember using the acronym PEMDAS, which stands for parentheses or brackets. Those come first, and you always work them inside out, then exponents, then multiplication and division. Notice I put them both on the same line. The reason is multiplication and division are pretty much the same thing, and they always have the same priority. So you may sometimes divide before you multiply. So you always work those ones left to right. Finally, you add and subtract. And same thing, sometimes you'll subtract before you add. Those go left to right as well, since addition and subtraction are basically the same thing. Or some of you may know, please excuse my dear Aunt Sally. And yes, I did Google image old women to find this picture. That's not my Aunt Sally. Okay, so let's do some problems. So we're going to evaluate each expression for the given value of the variable. Our first one will do 14 minus 2d when d equals -3. So again, since I'm evaluating, I'm going to take the -3 and I'm going to replace the d with the -3. So I have 14 minus, I still write the 2, and then for the d, I'm going to put in the -3. And now what I'm going to do for a lot of these, I'm going to make a little PEMDAS checklist so I remember to do each step and do it in the correct order. So first I look in parentheses. There's only the one thing in there, so that's done. There's no exponents, so that's done. So now multiply and divide. I have a multiplication problem here with the -2 times -3. So I'm going to do that, and that'll give me +6. So now I have 14 plus 6, and then I add those together, and I get 20. Again, notice I didn't write d equals. All I wrote was 20 because that's the value of the expression when I replace the d with the negative 3. Okay, our next one, we're going to do 3a plus 5 over 6 minus b squared when a equals negative 2 and b equals negative 5. Now, another thing you want to remember, fraction bars are like parentheses. So what this means, everything in the numerator is like it's in a parentheses, and everything in the denominator is like it's in a parentheses. So before we divide this big fraction here, we're first going to have to figure out what the numerator on top equals and what the denominator on the bottom equals. So let's put in our numbers for the appropriate variables. And since we have two of them now, make sure you put the a for the a and the b for the b. Sometimes students will mix up which variable goes where. And so I have 3 times 2 plus 5 over 6 minus negative 5 squared. And so let's make our PEMDAS checklist again. Okay, so first parentheses, and so we've got to take care of the numerator and denominator. So I'll make 2 more little checklists. I'll make them really tiny too. Okay, so for the numerator, I have no parentheses, no exponents. Multiply and divide, I have the 3 times 2, so that's 6. And then plus 5. Okay, then on the bottom, I have parentheses. I have exponents. Now, here's where some people get confused too. You might be saying, hey, Mr. P, there's 2 negatives there. Doesn't that make it positive? Well, not always, because you got to follow the order of operations. So the exponent I'm going to do here, I have to do negative 5 squared, which I'll write over here. That's negative 5 times negative 5, and so that's going to give me positive 25. So now I have 6 minus, and this whole thing, the negative 5 squared, is positive 25. And now, we would look at multiplication or division, and in this case, subtraction. So remember, 2 negatives don't always necessarily make a positive. You have to go in the correct order of operations. Okay, so now we can add and subtract in both of them. So I'm going to come up here. So we have 11 over negative 19. And then, if we could, we'd divide these. However, that fraction's not going to reduce. So I'm just going to put the negative sign on top, since that's a little more conventional. And for this one, we end up with negative 11/19. It's okay to get fractions for some of these answers, so don't freak out if that happens. Alright, next, 7 minus 4 times the quantity x plus y squared when x equals negative 5 and y equals 2. So let's put in our numbers for our variables. And there's so many tempting things to do here. Some people might be tempted to take the 7 and the 4 and subtract them first, because that's on the left. Some people might be tempted to take the negative 4 and distribute it into the parentheses. Some people might be tempted to do negative 5 squared and 2 squared. However, you've got to remember you've got to go in the correct order of operations. So if I look at my checklist, parentheses, I have some stuff in parentheses here to do, the -5 plus the 2, so that's got to come first. So -5 plus 2 is -3. Okay, that's done. Now I got to do the exponent. I have an exponent, I have to do -3 squared. Remember, it'll be -3 times itself. So now I have 7 minus 4 times 9. Then I have to do multiplication and division. So I have a 4 times 9, so I have to do that. 7 minus 36. And then finally, addition and subtraction. So I have -29. Okay, last thing I want to show, two problems, they look alike, but the parentheses make a huge difference. So again, I'm going to make my little checklist. So for the left expression, when I put in 3 for the x, I have 4 times 3 squared. And since there's parentheses, 4 times 3 is inside, I have to do that first. So I have 12 squared, and then the exponent, there's nothing else, and that's 144. However, for the right expression, when I put in the 3, notice that there's parentheses only around the 3 and not also around the 4 like in the left one. So now there's no more parentheses, that's done. I do have the exponent, so I have to do 3 squared, which is going to be 9, and then multiplication and division, which is 36. So parentheses make a huge difference. Make sure you pay attention to where they are. That's it for following order of operations and evaluating algebraic expressions. So now you should be able to try some problems.